Ladies and gentlemen, welcome to the next lesson in the Su-25T Cadet series. This time I want to talk about how the radio altimeter works and why some people are confused about it. The radio altimeter works by sending out radio frequencies that hit the ground, bounce back, and the time it takes equals the distance. It is not a radar altimeter, it is a radio altimeter. Radar stands for radio detection and ranging. Therefore, it is a completely different object, product, call it whatever you want. It is a radio altimeter. The way it works, as I said, is that it sends radio beams from the transponder down to the ground and then up again. On a plane, this is our plane. Whoops. This is our plane. We are looking at it through or into the side view. That's what it's called. The green dots or lines here are the radio altimeter frequency. It works by shooting perpendicular, not just below it, but at 90 degrees below it to the ground, and then bounces up. Remember that it works at a 90-degree angle. It is very important to understand that, because when you understand that, you know why it gives you the information it does. The most accurate altitude is measured when you're flying straight and level and the ground below you is also flat, like over the water. That means this angle is always 90 degrees and the angle at which it bounces back is always 90 degrees. Yeah, sorry for the pauses, but sounds like the Air Force is flying around outside. That means that if you start climbing, that beam is still being shot out at 90 degrees. That means that this angle here suddenly it is tilted upwards. That means the radio waves have longer to travel before it can reach back to the center, because it will always fire at 90 degrees. If you pitch up 10 degrees, it would not change down 10 degrees. It will always fire at 90 degrees. Therefore, as I said, when you climb, the altitude may change pretty fast because it is measuring forward. It has a longer reach. Also, when you're descending, that is important to know that it also has long. If you climb 10 degrees and descend 10 degrees, the radio altimeter have equal amount of distance to travel. Only when you're straight and level does it measure your actual height above terrain. That also means that when you're tilting or rolling, this is our aircraft looked from behind. When you tilt or roll, that angle also changes, so you can be perfectly level flight, but as soon as you roll a bit, you see your altitude radio altitude climb up very fast, and when you roll back you see your radio altitude decreasing very fast. It is because it always shoots down 90 degrees. So you can only trust your radio altimeter when you're flying straight and level. It is very important to note that it does not fire towards the ground. It fires or radiates at 90 degrees. Let's take a look at that. And the radio altimeter in the Su-25T only works below 1500 meters. So right now, as you can see, my altitude does not have a R after it. When you see a R for Romeo appear here, it means it now shows your altitude with the help of the radio altimeter. If you want your altitude in barometric altitude, take a look at your barometric altimeter right down here. That will always, with no exception, show your altitude in barometric pressure, no matter how close or how far you are to the ground. See how far? Let's do a straight and level flight, and okay, now you can see we are roughly at level flight, and we are measuring our altitude with the help of the radio altimeter. If I do a, let's say, a left row, see how fast it changes, because it shoots at 90 degrees, and how fast it changes back. That is why your actual altitude using the radio altimeter only is accurate when you're flying straight and level. See? That is what confuses a lot of people, especially when flying at night or at in clouds or in fog. So therefore, if you're flying really low, see, suddenly it changed from 1200 down to 200 meters within a few seconds. Let's do a straight and level flight. If I do a turn right now, imagine that it's pitch black, no other light. If I turn right now, I see, oh, I'm 150 meters above the ground. No, I'm not. I am only 95 meters above the ground. It is very important to understand how such an instrument works. That is why always remember that it shoots at a 90 degrees downwards, and it changes when your flight position changes.